Hello and welcome to assignment 3 of CYB 60004 Networks and Cybersecurity Frameworks, Security Aspects of the 802.11 Standards by yours truly, Wade Rushton. So, firstly, what is wireless? Well, it is the ability to transfer data using the electromagnetic spectrum, and what we have been looking at very recently in the cybersecurity networks and frameworks unit is wireless local area networks. There are a couple of different elements in order to establish a WLAN, and mostly you need to have a device and an access point or a base station. There are two different types of modes when you are communicating in this particular environment, and there's an ad hoc mode and there's an infrastructure mode. Now, there are a number of different devices which can be used in the wireless area, and they are becoming more and more prevalent. And we can look at things like smartphones, personal computers, gaming consoles, tablets. There's even headphones, and now kitchen appliances also have various Wi-Fi or wireless capabilities. In a wireless environment, there's obviously a very simple type of network layout, and as we kind of touched on in the previous slide, the key elements to that are base stations or access points and endpoints. And we just have a small diagram here of a router sitting in the middle, which is connected to a PC and to the internet, and it is beaming a wireless protocol to various devices in the environment, which include a laptop and a PlayStation 2, along with an Xbox 360. This is a particularly old picture. And those endpoints are capable of communicating to the router in this particular instance via a wireless medium. Now, moving along, we can see that there are a range of different standards, and we will get to them next. But 802.11 is a standard which was officially commissioned in 1997, and believe it or not, at that very point in time, the transfer rate or speed was about 1 to 2 megabits. Now, these standards are governed by the Institute of Electrical and Electronics Engineers, and there are a number of standards and a number of amendments to these standards over the past 20 years. Now, the most common standards these days, up until maybe a couple of years ago, were BG and N, but 802.11 AC is starting to become more available, and the fundamental difference between these standards really is the distance in which they operate, the megahertz or frequency range in which they are capable of communicating on, and the amount of throughput of data that they are capable of sending between devices. Now, at this point in time, I'd like to mention the Aloha Net is believed to be the first public demonstration of wireless packet data network in June 1971. It's very, very interesting, and as we can see, there's a map there, or a very small icon of Hawaii. Now, in this particular slide, this is a subset of the 802.11 standards, and you can see there is quite an extensive range there. This isn't the entire standard, the entire list of standards, but just the subset. So you might be asking the question, generally speaking, what can 802.11 really do? I mean, at a fundamental level, it basically ensures, and it is governed by the IEEE, that a device, if it is Wi-Fi enabled, which is also trademarked by the Wi-Fi Alliance, it will work within a certain set of parameters. Now, BG and N can support various different speeds of up to 54 megabits per second, and if a device is sold with the Wi-Fi trademark on it and with an 802.11 compliance, then that would mean that the device is capable of transferring up to 54 megabits per second. Obviously, this is an over-the-air interface, so we can't see how this transfer is occurring. There are no wires between the devices. And we did touch on previously the fact that it may vary in speed too. Now, speeds between devices are also subject to external factors, and that might be in the environment that you live in or a building that you reside in. So now we move on to some of the risks, and obviously if we have devices in our home, in our workplace, and for business or personal reasons, then there's obviously some wireless security risks associated with that. And we should really be considering the type of information that we are sending over these networks. And obviously these particular transmissions open themselves up to the opportunity of actors that might be monitoring the spectrum. Obviously, there's an openness of wireless technology, and this has seen actors access different systems or steal, maybe even destroy data. And I guess the biggest concern that we have around these particular types of attacks is that it targets the CIA triad, which is confidentiality, integrity, and availability. And potentially it could be the theft of personal information, which would be a compromise of confidentiality. It could be an attacker gaining access to data and manipulating the integrity of it, so changing specific details, manipulating that data in a certain way that we could be concerned with, or they might make the data completely unavailable, which would be destroying the availability component of the CIA triad. Coming into some of the risks or common wireless threats, we can see in this particular slide we talk a little bit about rogue access points or ad hoc networks, and this might be where an attacker could take advantage of a rogue access point and set that up within an existing wireless LAN. And the intention would be to fool the person who is trying to connect to that wireless network by maybe spoofing the SSID or something similar. But the user on the end of that device will realize, or won't necessarily realize, that they're connecting to the wrong network, and that could lead them down a couple of different paths. You might expect that if a user does get tricked into using the wrong access point or SSID, that they would notice that they would have limited resources in a work or an occupational environment, and they might cut away the access or the connection to that particular point at that point in time. But it just leads to the question that there are various ways that an attacker could take advantage of a wireless network, and rogue access points or ad hoc networks is definitely one of them. The next common wireless threat that I'd like to talk about is the denial of service, and this is probably the simplest of attacks to trigger, because an attacker isn't required to gain an excessive amount of resources in order to complete it. This can be done in a variety of different ways, and potentially just sending a very, very, very large amount of traffic to a specific target. We can see these types of things happen all through environments, businesses, and the world from day to day. And there are different ways that you could perform a denial of service, and because wireless uses the electromagnetic spectrum, there is absolutely the ability to interfere with the signal. Now, some research has led to understanding that the 2.4 gigahertz band is easily susceptible to different environmental factors such as microwave oven interference. So simply setting off a machine like that around a 2.4 gig range wireless device may disrupt that. And if you were to double, triple, quadruple that effort, then obviously you could cause some definite destruction or disruption in that particular environment. So I guess thinking a little bit outside the box, an attacker could absolutely plug in a something into an access point and use or identify an unused channel and then launch a DOS attack from there. One of the biggest problems that we have these days in the IT environment, and it is referred to a lot throughout cybersecurity, is configuration problems, and that is basically the human element at some point, somewhere, sometime will always make some form of mistake in the configuration of a device, application, service, piece of infrastructure, or the like. And this is definitely one of the highest rated vulnerabilities within the environment, as we cannot stop entirely that human element from, not intentionally, and that's another kettle of fish, but mistakenly making a configuration problem. Now, some of the byproducts of that are, when we look at the configuration of wireless devices in our environment, passphrasing, etc., people don't understand the implications of that, and they don't understand that these types of elements can be strengthened by using well thought through passphrases and ensuring that they meet a certain standard to uphold the security of their connection to the wireless network. Moving along, some of the threats and attacks have been identified in previous slides, but there are literally hundreds of different attacks. And I guess we'll just move very quickly through something like a passive attack, in which an unauthorized party can gain access to assets, but they don't modify its contents. And that was really, that's a part of a breach of confidentiality. These particular types of attacks could be eavesdropping or traffic analysis, and sometimes called traffic flow analysis. And some of their subsidiaries are eavesdropping, so where an attacker monitors transmissions for message content. And an example might be a attack is a person listening to the transmission on a LAN between two workstations, or tuning into transmissions between a wireless handset and a base station. Traffic analysis part really is about monitoring the transmissions for patterns of communication, and there can be a considerable amount of information gleaned from this, and it can be very, very beneficial to the attacker. Now, in terms of an active attack, that's probably more along the lines where an unauthorized party makes modifications to a message or a data stream or a file. It is possible for these attacks to be detected, but they're not always preventable. And in fact, no attack is really preventable. We can never, ever, ever in our IT environments mitigate a risk 100%. So masquerading, very simple concept where the attacker impersonates an authorized user and gains access to something that they shouldn't have. A reply attack monitors transmissions in a passive attack and retransmits the messages as a legitimate user. Message modification, where the attacker alerts a legitimate message by deleting, adding, or changing or reordering it. And in the denial of service attack, we prevent or prohibit the use of normal resources through bombarding it with something, which we touched on previously. So now we're moving into wired equivalent privacy, which was introduced as a part of the 802.11 standards, and basically it was put there to protect data during wireless transmissions between clients and access points. However, it didn't provide end-to-end security, so there was a vulnerability there, and it only protected the wireless portion of the communication. So that ended up becoming a problem. There has been known quite widely that there are weaknesses in the WEP protocol, and the vulnerabilities significantly limit its ability to safeguard that particular protocol. So there are a number of applications which you can get a hold of which can do work against this particular protocol, and I've just listed two there in AirSnort and WebCrack, but it was a good attempt to secure something. However, and inevitably through evolution, we've found that it wasn't as secure as we needed it to be. So moving into WPA, this was absolutely an improvement on WEP, and it was introduced in 2003. It is traced back to the 802.11i specification, and it increased the strength of the encryption and authentication protocols. So we also looked at, there was two different modes of it as well, with WPA PSK, and the standard was WPA. It can be sometimes referred to as WPA Enterprise, and it was developed for users who didn't have access or the ability to utilize an authentication server, and predominantly targeted personal use. So this wasn't really an enterprise grade platform of security at that point in time. And I guess that following on from there, there was the iteration of WPA2, which was yet again another improvement, and it really focused at strengthening the encryption capability. And then there was the advanced encryption standard as well, which improved authentication and key management controls. So the evolution has been not relatively fast, but uniform and at a good pace in order to secure people's data over wireless connections. So in conclusion for this assignment, I guess there is a fair bit to understand and a fair bit to take, but the wireless environment is forever growing and it's huge, and the 802.11 standard is one of hundreds of different types which are available, but it is the most common, it's the most popular, and it is the most utilized all over the world. Now, these standards are governed and managed by the IEEE, and I'm just going to make another note that Wi-Fi often gets mixed up and is actually a trademark of the Wi-Fi Alliance. So through the reading of this assignment, it was very interesting to understand that 802.11 and Wi-Fi aren't really the same thing, even though it's a common misconception that it is. Consumer and enterprise devices are delivered with an 802.11x standard, and this can be seen by simply going on to any big vendor of PC or tablet and having a look at what their Wi-Fi capability is. And you will notice in those particular specifications, they will nominate 802.11 BGN or AC in some cases. And finally, there's so many different ways that we can secure wireless pieces, wireless devices in our environment, and it doesn't just come down to having exceptional security. It can come down to the configuration of these things within the environment. It can come down to how we secure certain applications, services, or infrastructure as well. And there's just, it's far greater than just looking at one element. I would like to thank you for listening to this slide deck, and Sean, if you've made it this far, I really don't know how you have. I've probably recorded and re-recorded this particular part of the assignment for probably 6 or 7 times now, but thank you very much for taking the time to listen, and until next assignment, enjoy.